Hi, and welcome to this introduction to Docker, a very quick introduction into running and using and building and making containers. We will cover how to run existing container images with Docker. We will be making our own container images with a Dockerfile. We will be running multiple containers at once with a Docker Compose file, and we will be looking at some common commands along the way. First up, we have a lecture about running existing containers. Hi, and welcome to the first lecture of our very quick introductory course into Docker. In this lecture, we will be pulling and running some existing containers. I can go into a lot of the theory that you would need for these certificates, like your CKAD or KCNA, but that's not the kind of course that I'm looking for to create. I want to create a course that people can watch during their commute and then understand a bit of how these things would work in practice, and not so much the theory behind it. So let's start with some basic terms. The most important is a container versus a container image. It's kind of similar to a house versus a blueprint. The container image is just a bundle of all the software required to run your application. And a container is an instance of that image. So a single container image, for example, a Node.js image for running your backend server. With just one image, you can create a whole bunch of containers that run independently on different servers, for example, different time, not time zones, but different regions, etc. So again, just to summarize, it's a house versus a blueprint. We also have some basic commands. Docker has a lot of commands, and if you type docker help, you will get a lot of these already. We will not be going through all of these, but just know that with docker help, so no dash help, you can get this whole list. Excuse me. We have some commands like pull for downloading an image from a registry, pushing, which we will not do. In fact, I don't think most developers would. Maybe if they have their own registry, but we never did. PS to list containers. We have RM somewhere right here, or at least we should have that, to remove container instances. All right. So I mentioned a registry. Docker has their own registry. You can use external other registries if you want or if you need to. But most of the time, the Docker registry is enough because we have a lot of official images right here. It's hub.docker.com. And I'm searching on the official badges, which has images like Nginx, Alpine Linux, Redis for your caching, Postgres for your database, maybe even MySQL. Just a lot of these official images would be enough for most developers to use, right? We will be playing around a bit with Alpine. It's a very, very minimal Linux distribution, and we will also be taking a quick peek at Nginx, and if I'm not mistaken, the Node image as well, but that's in a later lecture. So let's clear this and let's go to the showcase. So these are all the commands that you could run basically if you have Docker installed. So you could do Docker version, and you can see we have Docker installed. I recommend installing the Docker desktop. It's a lot easier on most Linux distributions as well to install, and it just fixes all the other things surrounding Docker that you need. So just run it. I have this like system icon right here, and it kind of looks like this. I had this the last time as well. I will just go to dashboard. Here we have a container that we had running some time ago, 2 days ago. It's not really interesting. It's just a nice GUI, but I am more of a CLI kind of guy. So that's what we will use as well, since it's more efficient and you won't always have access to the Docker desktop application. So first we need to pull the image. We can also specify a tag. As you can see, it is using the default tag latest. You can do that with a colon, so we can just say latest. And as you can see, the digests are exactly the same. I already have pulled this. If I will pull another, for example, let's just do Postgres. I think it's called PostgreSQL. Nope. Postgres. Then you can see it's downloading in these layers. We'll be talking about layers a bit later on. Just think of it as certain steps in a Dockerfile that can be cached. So once you have a few layers cached and one of the layers is updated, it doesn't have to pull everything again. So this just makes it a lot faster. All right, so we have pulled Alpine with Docker pull Alpine, and then we can say Docker run Alpine, and nothing really seems to happen. We don't get an error, so it should be fine, right? Let's just do Docker PS. Maybe it's still running. Let's make this a little bit bigger. Like maybe it's still running. No, it isn't. So Docker PS -a, which will list all your containers. Let's make this a bit bigger again, because this command has a lot of columns, right? So we didn't use any ports, which is correct. If you hear my cat meowing at the door, I am sorry. I hope that it doesn't really distract, or I hope that you don't hear it as well. So here we have our Alpine image that we ran. It ran the command bin shell. It was created 28 seconds ago, and it has exited with a 0 status code. So that's positive, right? Let's make this smaller again. Let's clear this. So as I mentioned, Alpine is a very small Linux distribution. And we can run commands in the Docker image or container if we want. To do that, you would just say Docker run Alpine, and then you would specify the command that you want to run. Not in quotes or anything, just the command like you would always write them. So let's just output the OS release file from /etc. And then you can see we, again, Docker PS, it's not running again, but we have this output from our Alpine Linux, which is cool. So that's how we could run a command. If you want, you could also run something like top that doesn't close, right? If we do that, we just get top, and we need to close it ourselves with Control-C. Let's clear it and let's Docker PS. All right. But what if we don't want our terminal to be, to have everything in that server running? Like, for example, you don't use tmux like I do, so you can have multiple panes with multiple terminals. Then you can use the docker run -d to run a detached container. And then again, Alpine top. As you can see, it gives us a hash. If I do docker ps and make this bigger again, we can see that we have a container running actually. It didn't close. 4 seconds ago it is still up, which is positive. It's the Alpine image, and the command that we are running is top. So let's try and get into this container. Docker exec, it's actually -it, which stands for interactive, and the T stands for T2Y. So we will execute a interactive terminal within our container, and we can specify it with the container ID, if I'm not mistaken. So 883F, you don't need to use the whole ID. You could also use the name. And then it's whatever we want to run, actually. No such container, so I have these wrong. 883F bin shell. All right, so right now I'm in the container. We are in the running container, which you can see since I don't have my usual fancy prompt. If I do ls, you can see everything that's within the terminal, and if I do ps, we can see that we also have our top command running still, and it's actually on pid 1, which is pretty cool. But the top is still running. Okay, so if I want, I can probably kill that. I don't think so. I thought I could maybe kill okay, the top command, so it would close, but we can't, or at least I don't really know how at the moment. But we can exit the container. We've looked around in it. If you want, you can add some files, update some configurations in this way. But let's just kill the terminal, right? So docker rm, and then we again can use docker stop. We need to stop it, and then we can remove it. And then we will not see it right here. So we had the 883F. It doesn't show up right here. So again, very quickly to recap, we pulled an image, we tried to run it. We tried to run it with a command that it could run. If the command doesn't close automatically, it will keep the container running. And if we use the -d flag, it will keep running in the background. We could also use the --rm flag to automatically clean up the container after it's closed. Let's very quickly show this. --rm alpine cat /etc/os release. If I do docker ps a, you will see that our last created image or container was 4 minutes ago. So, and that was with top. And this one was exited 4 minutes ago, so it's again not the same. So --rm will just clean up automatically. Then if we have a container running in the background, we can use docker ps to find its ID, and we can use docker stop and docker rm to stop the container and then remove it from our ps-h or a. Next up, we will be taking a look at how to make our own images using a Dockerfile. Hi, and welcome to this next lecture in which we will be making our own container images. Of course, we have already taken a look at how to run these images. so I will not be talking about every command that I run. Docker files are built out of layers. I already mentioned this in the last lecture just very quickly. These layers are created out of these commands, like from node 18 creates a layer, work their app will create a layer, etc. These layers are like steps in a recipe. For example, you need to cook for a ton of people. You won't chop all the vegetables for each meal again and again and again. No, you will chop all the vegetables that you need at once, probably at the start. And then when you arrive at the step to chop the vegetables for each recipe that you execute, you can just skip it, since it is, in a way, you have cached your vegetables, right? So these layers are cached, so building will become a lot quicker. And we will see this in a bit as well, because I have already messed up this recording a few times, so a lot of things are cached on my machine at the moment. So what we want to do is create a quick server. I already have a index.js, which looks like this. We don't have any package.json or anything. We can just run node on this index.js, and we have a server running that we can curl to get a response, right? So, whoops. This is the code of this script. If you want to pause and type along, you can do that. You can just create another script in any other language that you want. But since we will also be using the node image, you might want to do it with a node server. Right? Okay. So if you want, you can try this with another language if you want. Or if you want to try that immediately, you can also do that. So let's create and build a Docker image. So let's vim Dockerfile. A Docker image is built from a Dockerfile with a capital D. Let's start with creating our first layer, or using our base image. I'm sorry if you can hear my cat screaming at the door. I will not let her in. So from node colon 18. This might look similar. It's from we pull the node image and we specify the version tag of 18. You could use latest, but since breaking changes would happen often, you're better off just using a specific version. And if that happens to be the latest version at the moment, that's fine, of course. But that way you can just upgrade it and keep all those breaking changes in check, right? So we will use the node 18 image as our base image. We'll also be using a app directory as our working directory. This will make sure that we do not copy our files, our whole server, everything into the home directory, because that just looks awful, right? Next up, we will copy our, let's just see. Okay, I have copied it already into the home directory, or into our working directory. We will copy index.js into the working directory that we've used with a dot. Keep that dot in mind. I have already forgotten countless of dots in the years, and it's horrible to debug. And lastly, we will be running our server. And now you kind of have to do this in this weird string array kind of way. Of course, in a terminal you would just run it like this, but we will have to specify it like this in a Dockerfile. Okay, so let's just check. With Docker images, you can list all your Docker images, right? I have already built this a few times. As you can see, demo is created 2 days ago. Yeah, that sucks, but yeah, we have tried it a few times. We have created it 2 days ago. If we want to build it again, we want to tag it with the name demo. We use this -t to give it a tag. And we want to run it from, or build it from the Dockerfile in our current directory, again with a tiny dot. So this will build it. As you can see, it built within a second because we have some cached layers. All right, so we can clear this. We can, whoops, build it again. It's so fast. So we can list it with Docker images again. If you didn't build it before like I did, it will now have shown up right here. If you don't specify a name, it will become this like none. Okay. And it's not bad or anything, but then you would have to run it with the image ID. So let's run it. Docker run demo. Okay, we have a server running on port 3000. Let's curl it. Hey, it doesn't connect. But why is that? Right? Is the server running? Like, let's enter our let's enter it, right? Let's enter it, the image. Node is of course a command that doesn't close, and we can see that it's running because we haven't detached it yet. Let's do this. My terminal is too small. Sorry for that. Okay, image demo has a container ID of 85 with some more characters. So let's docker exec a interactive terminal on our 85 or our demo, the container ID. And then let's do bin shell. All right, so now we are in our Docker container. You can see that we have we immediately enter our app directory, which is pretty cool, I think, in my opinion. But let's just curl right here in our container. Okay, so our script is working. We don't have an error, not even a runtime error, at least not that we can see. So what's wrong then? Hey, you might have spotted this already, and my acting is terrible. We need to map the host port to the container port. We need to specify, okay, this container has something in this port, and we want to have it in this port on our own local machine. So let's close this, and let's do docker run -p with our port. We can just map it to 3000 because that's just good, right? So let's curl again. Hey, now we get a response. So we have a Docker container running with our small JavaScript script that will return hello world. And we now have access to that from outside of the container. So this is kind of how a container would work. You create a Dockerfile, which makes all these layers. You would build it, and you would run it. And if you need to, you can expose these ports. You also have the expose keyword, and you can do expose 3000 in your Dockerfile. But I won't get into that since this is a very basic introduction. All right. So next up, we have an introduction to Docker Compose files, which is another way of running containers. Whoops. See you in the next one. Welcome to this lecture about multi-stage Docker files. Why do we want to create a multi-stage Docker file? Because it is more complex to create, so why go through all the effort? The most important part of that is saving space. We will see in a moment that it can save a lot of space, having a multi-stage container versus one single stage container. It is more secure because you reduce your attack vector, and you have faster deployments because they are so much more tiny. So let's try it. Right here I have a hello.c file, which is just a regular C file that prints hello world, right? We compile it using GCC, and then we can do a.out and it prints hello world. That's not really interesting at all, right? So let's remove that. Let's containerize this, right? So let's create two Docker files. One that is a single stage Docker file. So let's just, I think I have test right here. All right, that's fine. Dockerfile single. So let's create a single stage Docker file for this first. We will start with Alpine Linux. Let's just take the latest. And we don't need as builder or whatever yet. So we run the package manager, and we need to add GCC and some dev dependencies, right? So then we need to copy hello.c to our working directory. We run GCC. Let's output it into a file that is called hello. And then we just say cmd hello. Whoops. Okay, so this is the single stage Docker file, right? Let's clear this really quick. Let's see if I have anything running. I mean, I guess I have kind running. Docker stop 01. That takes a while. Let's ignore it for now. So I have kind running. Let's see what images I have. I have a bunch of images, but these are all created long ago, so we can also ignore them. So let's do docker build, and let's just run the single Docker file. Let's call it single stage. Oops, that is of course right, because I need to copy hello.c into our directory right here. There we go. So now it is building, and it takes a while, right? 2 warnings. Let's ignore the warnings for now. Right, so okay. Docker images. All right, so we have our single stage image, which is a whopping 250 megabytes. And we can just run it. Hello world. Nice, cool, right? So let's now create a Dockerfile multi. Let's create the multi-stage. Let's actually create, or whoops. I kind of want to copy this. There we go. But now we will say as builder. So the as keyword here is important. This will signify that it is a excuse me, that it is a multi-stage Docker file, and this will signify that the first stage is called builder. So then from this, we don't need this, all right? So let's see. Then we do pretty similar to our first one, Alpine latest. Let's, whoops, copy that. And right here we do copy from builder. Whoops. The dash hello into dash hello. So what this does is we have our build stage, right? We download the packages that we need to build, which is GCC. We copy the file that we need to build or that we need to compile. We run GCC to compile the file into a file called hello. Then we create another, like, quote unquote image. We copy from that builder image the hello file, and we call it hello on the new quote unquote image as well, and then we execute it. So let's find this one. Let's create it, let's call it multi, and right here as well, multistage. That looks good. We have the same errors or warnings rather. I forgot some casing, some uppercases I saw. So let's do Docker images right now. Okay. So our single stage right here is still the 250 megabytes. Our multi-stage image is just 13 megabytes, which, well, yeah, that's like, my math is probably way off, but I think 20 times as small, right? So let's do docker run multi-stage, and it is just the same, right? So yeah, that is why you should go through the effort of making a multi-stage Dockerfile, because you will pretty much always have some developer dependencies that the user doesn't need. So the conclusion is use multi-stage images if you can. And now you know how. Hi, and welcome to our last real lecture on Docker. In this lecture we will be talking about Docker Compose, which is a way to compose multiple containers together and run them very easily. So why use Docker Compose? Well, instead of running our archaic Docker run with -p and maybe -it, you know, we can just set up a YAML file that any developer can run with a single command, and that command is always the same. I've often used this for development setups. For example, you want to run a Redis database, a Postgres database, maybe some other things. I think we had a mock Google Cloud platform as well at some point for running tests. You can do all these things in a single Docker Compose file. This also saves a lot of headache with versions and such, right? Okay, so for our showcase, we'll just jump right into it because it's better to see what it does than explain how it works. We have Docker Compose or Docker-Compose. These both should work, he said confidently. Here within our Docker desktop, we have a enable Docker-Compose CLI alias. For some reason it doesn't work on my computer right now, which is pretty horrible and I feel bad. But yeah, I think it used to be Docker-Compose, but nowadays you can just use Docker space compose as well. I use Docker space compose. I've used Docker-Compose. It doesn't really do anything. It's just an alias, right? That just doesn't happen to work on my machine. But that's okay. to run a Docker Compose file, you would use Docker Compose up. You could use it with a -d flag to detach it again. So you have your terminal free again. It will run in the background. And if you have done that, you can close it with Docker Compose down. For the showcase, again, we will verify it with our local host, right? So let's create a Docker Compose file. It's called dockercompose.yaml. Older versions used a version at the top, like this. We could do that. We will probably get a warning that it's outdated and we don't need it anymore. I think it's the version of a Docker Compose file. So let's define our services, because in this Docker Compose, we want to have multiple services. Oops. I used P instead of O. Let's use our own demo Docker file that we have had in the last one. Image demo. And let's do this to expose our ports. Whoa, sorry for that. I need to indent these by 1. So what this will do, we have a single service in this Docker Compose file right now. A single service called app. This can be any name that you want, app, database, whatever. And we will build it from the Docker file in the current directory, which we have made in the previous lecture. This image is called demo. And we want to map our ports from the port 3000 from our Docker file into 3000 of our own PC. But that's not where Docker Compose gets interesting. Let's create another server, for example, another service called server, which will use an existing image. So image, we will be using Nginx. For the sake of this demo, we will use latest. Nginx would run on port 80 by default, but let's use 8080 on our own PC. So now we have a Docker Compose file, a Docker Compose.yaml with 2 services. One that we built from scratch from the Docker file in our working directory with an image called demo, and we map the ports, and we have a server with image of Nginx with some mapped ports as well. So let's just run Docker Compose up. Ports must be an array. All right. Okay. Like so. All right. So I had this wrong. I needed to have it as a dash, right? Like so. So Docker Compose up. We can see that a port is already allocated. Let's see, it's port 3000. It probably has to do something with our previous lecture. Let's just make it 3001 right now. Okay, so what do we have now? We have a Docker Compose running. We can see it is running 2 containers, container Docker Course server and Docker Course app. Docker Course is of course this directory. One it has recreated because again we had some previous takes already, and the other one is running, which is great. We didn't run it in a detached state, so let's create another terminal and let's curl localhost 3001 because keep in mind we mapped the port to 3001 because I already had 3000 running somewhere else. But the app that we use just prints this. All right. So that's cool, but let's check out what we get from the Nginx port. We get some HTML, which is correct because this is the HTML of the welcome image for Nginx. So if we do localhost 8080, we can see welcome to Nginx, which is this HTML. And we run this from our Docker Compose. We can also see that we get some warnings, or not even warnings, sorry. These are just the responses, the things that Nginx will print. We have a get request, another get request for the favicon. No such file because we don't have a favorite icon. But yeah, like both these containers will output their logs in this single view, which can get, well, not really annoying. It's very useful. We also have the warning of the version attribute, which is obsolete. And I already mentioned that when we created it. So let's use Control-C to close these containers. You can see that it has stopped the server and then the app. So we don't have anything running right now. Anything new running right now. These were just the demos from 10 minutes ago. So let's do docker compose up-d and let's curl 8080 to see that it works, but we still have this terminal free right now. So if I want to close them, I just use docker compose down, and it will then try to stop both of these containers. For some reason the app takes a lot of time to close, but that's okay. So that's how you can use the -d command, which is just very great because you don't have to look at it all the time. In a very small nutshell, this was our introduction to Docker. So up next is the conclusion. Let's again very quickly take a look at our Docker Compose, which just looks like this. We have once again made it to the conclusion. First off, let me say thank you very much for watching, and I hope you have learned something about Docker. Just how to build and create basic images, how to run them, and how to build and run a Docker Compose file. So we have covered how to run containers with the Docker CLI tool. Again, remember, just install Docker Desktop as it removes a lot of the headache. If you get any problems with your terminal saying that Docker doesn't run, just open the Docker Desktop app and it should start all the daemons and the services. So we can use the CLI. We have checked that out. We have created our own image right here with a Dockerfile. It was just a very basic image which will run a simple server. But as you can imagine, for a node project, it doesn't really get that much more complicated than a basic workflow like this. We've also seen how to build this and how to run it and how to map the ports with -p. We've also taken a look at creating this Docker Compose file in which we don't need the version attribute anymore. We have seen how to build or create this file with multiple services. We have seen how to map these ports and how to run this in a very simple way. And we've of course also taken a look at some very basic commands. Again, thank you very much for watching. If you enjoyed my style of teaching, which is fully in the terminal if I can, So I have multiple courses in which I have this same workflow with some slides on the left side and then some practice on the right side. You can check out my other courses. And if you don't, that's fine too. If you're interested, the tool I use for the slides is literally called Slides, which just uses markdown files. So a slide deck looks like this for me. All right. The tool that I'm using for these 3 terminals within a single terminal window is called Tmux, which you might have spotted at the top. It's very interesting, very useful, I think, especially for developers and for DevOps, because I only have to have a single terminal window open at the time. And I can just switch between these, which is great. And of course, I have used Vim because I love working with Vim. And my prompt is Starship, which is another great little tool written in Rust by people smarter than me. Again, thank you for watching. Just to really summarize, we have created our Dockerfile, which is with a uppercase D, which looks like this. We have created our simple Docker Compose file. And we have run and built containers. We have done it everything. And you are now a little bit more prepared for your Docker journey. Thank you for watching.